Okay, problem number 7. Again, they're looking for commensurable roots, what I would describe as being rational roots. I would not say the word commensurable, but it's same meaning. So we're going to write the candidates down. It's really the factors of 24. Let me point that out to you. Give me 1 second. So the factors of 24 divide by the factors of 1. So I write the factors of 24 down, divide by 1, and you get a list over here. The problem with a long list is that if you just thuggishly check each one separately, I'd say it's kind of unproductive. But, where are you checking it? Let me just write that down for you. I certainly typically write down a function, f of x, and I'm looking for the roots of the function. The function's x4 plus 10x cubed plus 35x squared plus 50x plus 24. Now, one thing I want to point out, kind of looking at it, even though I start with 1, it's not a good choice because everything would be positive and there would be no way it would be 0. So, I put the F1 down as 120, and then you go like -1, and, F2 would also be a ridiculous one to check out. It gives you definitely a positive number, and then you get this over here, right? This gives it to you. So they were low in the list, and I would say -1, -2 is the one we're going to start with. I'm going to write that down for you. So if -1's a root, x plus 1 would be a factor. And if -2 is a root, x plus 2 would be a factor. I would multiply that out, and you would get x squared, right, plus 3x plus 3. Now what I know that this, I'm sorry, I made a mistake there. I just saw it. Again, you can you can do this by long division or but what I call equating coefficients. But let me just write this down for you. So 3x plus 2. Now this is a 4th degree polynomial, and so I'm going to have to match it up, right? So it's going to be a quadratic here. That's x squared. And 24, what would I have? It would have to be, let's see, 12. Now I'll put the plus down. What I don't know is the internal term. I'm just going to call it bx. All right? But if I multiply it out, it would be f of x. Now certainly I get the first term and last term. It's these middle guys that are killing me. So I'm just going to focus in on one at a time. I want to see if I can get this. That's really a cubic term, right? And what do you get there? It would be, where'd the cubics come from? So x squared times bx would be bx cubed. And then another one, you'd get the 3x cubed. So, x squared times bx and 3x times x squared. And that would have to equal 10x cubed. Well, looking at it by inspection, b has to be 7. All right? Let me get my eraser out. And I'm going to erase the b and put 7 down now. I'm going to erase this 2 over here. All right. Now, certainly we can check that if you like. And what I'm going to do over here is, maybe let's check it. So what you get? Let's just check make sure we get the 10x cubed now. So what do you get? You get 7x cubed plus 3x cubed. Bingo, got that. Let's see if we can get the other guy, which is going to be the square term. What would that be? Well, 12x squared. Let me write that down for you. 12x squared. Let's see, 2x squared. And then 21x squared. What does that give you? Let's see, 12 and 2 is 14. Yeah, 35x squared works beautifully. Get my eraser out. And let's just make doubly sure I get that 50x in the end. And I'll do that by, multiplying it out. And 50x, what would you get there? Let's see, 14x That's 2 times 7x, and 3x times 12 is 36x. Yeah, lo and behold, we get 50. So everything's working out as advertised. All right. Now, granted, in notes I probably used long division, but let's factor it now. And to factor it, I certainly note the first guy factors, so I just did it. Sorry. Let's see. I think I might be able to do that. Let's take a look. It looks like 3 and 4. So what are the roots going to be? The roots are going to be -1, -2, -3, -4. And again, they're rational roots, and I do see in the list 1, 2, 3, and 4. All right, all negative. All right, so I guess we could also graph it out, just get a rough idea what it looks like. And again, my pictures are going to be very rough. I'm hoping they're going to give you a better picture. So like -1, -2, -3, and -4. It's a fourth degree polynomial, and the y-intercept is going to be 24, so maybe something like this over here. And it's going to go straight up over here as well. And then I guess I could, take test points. And a good test point would be like -1.5. And that would be over here, -1.5. Plug it in. You're plugging it in actually here. This is the factored form of it. And what would you get, -1.5? It would definitely be negative. You get something like this over here. All right. Then if you took a test point like -2.5, well, you get negative times a negative. It would be positive, something like this over here. And then you get the feel for it, -3.5, it would be negative. All right, this is a rough picture. And what I want to do is look at the key now, and I want to just see if we're getting what we're expecting to get, which is the roots. Did I get the roots? They're listed right over here for you. Whoops, sorry about that. As we stated, -1, -2, -3, -4. And they provide a graph. And the graph is actually better than mine, but I want to point out it's still, roughly the same. Mine was more exaggerated, and that was 24 up there, right? And what my sign analysis, remember I did something like this over here, straight up, straight over there. I did sign analysis over here, this, I got that, I got something like that. Again, it's important you realize that when I'm doing a graph by hand, it's a rough visualization of what it is. When a machine's doing it, it's actually doing a much more precise visualization of it. And these things you can zoom into certain areas, get an idea exactly what it looks like. Certainly we're getting, a local min over here, a local max over there, a local min over here. All right. So that's done. These are not bad problems. Again, I do it by division in this case over here. But again, your mileage may vary. You do it the way you want to do it. Let me just remind you who I am. I'm Ron Bannon. If you need to reach out to me, my email address is Bannon. It's B as in boy, the @ symbol, NNON.US. Thank you.